All right, guys, I need you to not hate me. I'm sorry that I'm not here today. I'm going to get one of my brackets fixed. So, all we're doing today is finishing lesson 3, where we talk about what the actual graph looks like. And yesterday we talked about the numbers and how it's spread, and today we're going to look at the pictures and how it's spread. So let's look at this page. And if you recall, the last thing we tried to end with yesterday was graphing these as a histogram, and my software wasn't being nice to me, so we're just going to look at some already drawn, and hopefully the last one we do, we can get on a box and whisker plot. We'll see how it goes. All right, so we've all seen a histogram, right? We know what they look like, or a bar chart, and so when we graph those, it's really easy to tell how it's distributed, the data is distributed. Like, are they all about the same? Are they even? Are there more big numbers? Are there more little numbers? That kind of thing. So here's the 3 different kinds of what are called distribution. First, we have when it's skewed left, when it's symmetric, which is, again, also called normal, and then skewed right. So the skewed left and right always kind of got me. Because if it's skewed left, you can see here there are actually more numbers on the right side. And if it's skewed right, there's more numbers on the left side. Okay? So here's what I need you to know. When there are more numbers on the right or the left, it's skewed left or right, we can see that the mean, median, and mode are all not the same, right? The mode is going to be the most, so that's always going to be your tallest number. Right, we can see that here. And depending on where the numbers are, if there are, more smaller numbers or more larger numbers, that's going to affect where your mean is and then where your median is, okay? Now, if it's normal or symmetric, the mean, median, and mode will all be right down the middle, or they'll be all very, very close to each other. Okay, that means everything's just normally or equally distributed, and that's usually really good information. So if I asked, I'm just going to go down and do the answers here. If the mean is greater than the median, so let's look and see which one that is. If the mean is greater than the median, so here's the mean. We can see that it's greater than the median in this one, right here. The mean is bigger than the median, right? It's on the right side of the median. Then we know that it's skewed right. If the mean is less than the median, okay, so if the mean is less than the median, right here, then it is skewed left. And if the mean, median, and mode are all equal, then it's symmetric. Okay, so we can see that by that lovely graph that they gave us. Okay, so question number 2 says, Libby says a data distribution that is skewed right has a mean, median, and mode in the center of the bell curve. Well, that's not true at all. It's obviously not in the center. We can see here's the skewed right here. It's definitely not in the center. So we wouldn't say that it was skewed right. We would say that it is symmetric. We can see that the ones that skewed right, that the mean is larger than the median and the mode, right? So that's the problem there. Okay, so again, just making sure, reiterating one more time to make sure we understand all of this. So if it's skewed right, again over here, the mean is larger than the median. Like if I had all of those numbers and I figured out the mean, median, and mode, the mean is going to be bigger than the median of that set of data. I believe, no, that's not what happened yesterday whenever we did those tests on the board. Whenever it's skewed left, the mean is less than the median, right? We can see that here again on this one. The mean is less than the median. That's actually what happened yesterday. Whenever we did those grades, the mean grade was like an 87, but the median was like a 90.5. So that means there were a lot of really good grades on that test. And if you look back over those numbers, if you saved it on that Google Sheets, that was obvious, right? There were definitely a lot more bigger numbers there, so that would have been a skewed left graph had we had actually got the graph to work. And then, of course, we have symmetric is the last one. The mean, median, and mode are all equal. Okay, so this is a really important page. So make sure you have all of that and understanding where the mean is smaller, larger, and where they're all the same. All right, so let's look at this back page. Now, this back page, I'm not going to do all of together. As a matter of fact, I would really, really like for you to, excuse me, do number 1, A and B. I showed you guys how to do that yesterday on Google Sheets. I would really like for you to try to find the answers to those. Okay, so remember, you're going to go type those in, and you're going to use those formulas to find the mean, standard deviation, min, max, first and third quartile, and the median. Okay, so that's what we did yesterday on Google Sheets. I would really like for you to practice those two and go find those, okay? So here's the problem on numbers 2 and actually number, I believe it's 5. Like, I need to be able to graph this. Excuse me. So I'm going to do that in a minute on, on that online calculator that I showed you a minute ago. But first of all, let's go ahead and answer number 3 and number 4, and then we'll come back to number 2 and 5. So number 3 says, every other week, a horticulturist sprays fertilizer on the roses in one section of a garden. Do you expect the height of the roses in the garden to be uniformly distributed, right, symmetrical? Uniformly meaning like all the same, like they're all going to be the same height. Normally distributed, meaning some are going to be small, some are going to be big, some are going to like in proportion. Or is it going to be skewed left or right? Now remember, we talked about skewed left and right. Going back up to my picture here. If it's skewed left, there are going to be some that are bigger and some that are smaller and skewed right. So let's think about what this would mean as far as fertilizer goes. If you sprayed more fertilizer on more of the garden, okay, so more fertilizer on more of the garden, then you're going to have more be taller and fewer be smaller, right? But that's not what it's saying here. It's only spraying one section. So what's happening in this particular graph is you're not spraying as many, right? You're spraying, the less you're spraying fewer like that. So that's what this graph is going to look like. I know that's probably really hard to visualize, but you can think about it that way, right? The less the spray, the smaller. The more the spray, the taller, right? So this one is actually going to be a skewed left graph. Okay. Again, just go with me on that one. That one's a little bit harder to explain. Number 4 says, describe the shape of the distribution of a set of data where the median and median are the same. So if they're the same, then it's symmetrical, right? We talked about that a minute ago. That's the one where it looks like an actual curve, like in the middle curve. And it says, how would the median and mean compare if the data were skewed left? Okay, so if it's skewed left, the mean is less than the median. Okay, so we can look at that. So if it's skewed left, the mean is going to be less than the median. Again, like what happened yesterday when we were talking about those test scores. There were a lot of really good test scores, and so that's why it turned out that way. All right, so in order to be able to do numbers 2 and 5, I need a picture of this data to be able to tell whether it's smaller, bigger, whatever. So I'm going to choose to use a box and whisker, especially on number 5. Excuse me. So I'm going to go to Google Classroom, is what I did here. And then I went to the statistics calculator that I posted yesterday, and I went to the box and whisker. So that link is there in Google Classroom still. And I'm going to type in these numbers. Go away. So I'm going to type in these numbers. Now, don't use the commas in the numbers, okay? So 1022, just type it in 1022. And you can enter, like do one on each line. So I'm just going to type these in real quick. Okay, sorry, I got interrupted. So anyway, so I'm just typing in the numbers. And we're going to look at what the box and whisker. It's basically the same thing. It's just instead of a bar, it's a box. Surprise, surprise. It doesn't matter what order you type these numbers in, by the way, as long as you have them all in. It would help if I typed them in correctly. And then the last one. Okay, so once you get all of the numbers typed in, and hopefully I have them incorrect, just click on calculate, and there's the picture. And what's really cool, and I'm going to actually use this for number 5, is that if you scroll down, notice it gives you the min, the quartile 1. Why does it do 0? I must have accidentally put a space in there. Okay. Let's recalculate that. Whoops. Gosh darn it. Okay. There we go. Accidentally put an extra line in there, and it counted it as it being a 0. So you can see the min, the quartile 1, median, quartile 3, and the max, right? It gives that to us. And it gives us the skewness shape. So see that how it says it's potentially symmetrical? That's awesome that it tells us that. And you can see by the box and whisker that it's sort of in the middle. You can see sort of that it's a little bit skewed to the right a little, but really, what's nice is it tells us down here again, this is skewness shape. It's potentially symmetrical. Okay, so that's one really cool thing, again, about our software. Okay, so that would be the answer to, let me go back to our program here. Again, it says describe the shape. So we're going to say that it's potentially symmetrical. And it says which distribution measures best describe the data. Okay, so if it's symmetrical, you want to use the mean and the standard deviation. Okay, the algebra ones that I was talking about yesterday, where we had to do all that math, but again, our program will do it for us. But on number 5, so let's look at this one. I think I want to use Google Sheets. Do I want to use Google Sheets on this one? You know what? I don't know if Google Sheets, if I even have it on here. So, oh no, I do. Okay, cool. All right, let's put it in Sheets and let's see what it's going to give us. Bump. And I'm just going to type in the numbers. Again, I'm really not sure how user-friendly this is going to be. It might not let me do a graph. Let me see what it's going to let me do. I don't think it's going to let me make a chart on here. I can still do the other stuff, though. So I'm just going to go ahead and put in these numbers. There we go. Okay, so I'm just going to type in the numbers. lost my place. Oops. It's supposed to be 13, not 113. Okay, I think I got them all in. Maybe. All right, so I can enter a formula, right? So I'm going to do, here's asking me for the mean, the median, and the standard deviation. So I'm going to type in that equals, remember it's the word average. I want to find the average of this column. Let's see if it's going to let me highlight it. Yeah, boys. Okay. All right. There you go. So there's the mean. It's about, that seems wrong. No, that's probably about right. So that's the mean. The median, remember you're just going to type in equals median. Now listen, if I did do this wrong, y'all know how to fix it. I'm going to type in A1 to I believe it was 21. I think I might have typed in one extra number. There we go. There's the median. The standard deviation, remember it's going to be equals. Start typing in standard deviation. It is the first one. Again, we do standard deviation of A1 to A21. It gives me that number. And I obviously, I don't have a picture here, so I don't think, and this is the unfortunate part, I don't think it's going to let me insert a graph. But you can, right? Ah, haha, there it is, chart. I want a column chart. Not a line chart. There we go. So you can see there's our chart. And we can see that it is actually a little bit skewed right. I can't draw on this page, but there you can see there is more stuff on the left than there is on the right. It's higher on the left than it is the right. So this is a skewed right graph. Okay, so that's number 5. Again, there's the mean, the median, and the standard deviation. Again, I think I might have accidentally typed in a number wrong there because this looks weird. But that's the mean age, the median age, and again, the standard deviation is the number that describes how the mean is like spread out. And it's skewed right is the answer there to number 5. So what I want you to do is I want you to use the last of the class period to practice using Google Sheets to answers number 1A and B. All right, you guys have a great rest of your day.